My name is Kareem Khalifa, and today we'll be paraphrasing quantified sentences. Today we'll cover two topics. First, we'll look at what I call tricky sentences. These are sentences that are not easily translated using some of the techniques that we've talked about thus far. Second, I'll point to an ambiguity in English that's made explicit once you formalize this stuff, what are called weak and strong readings. Let's begin with tricky sentences. I'm going to proceed in two steps. First, I'm going to make explicit the method that we've been using for translating quantified sentences thus far. And then I'm going to give you an example where that method kind of breaks down. These are what are called donkey sentences. And they're just an example of a number of places, in fact, where this method is not watertight, but is nevertheless reliable for a lot of other kinds of sentences. So we can think of our method as consisting of three steps. In the first step, we take a quantified sentence, we then translate the subject of that sentence into first-order logic, and we leave the rest of the sentence, which itself is typically a sentence, untranslated. So we've implicitly been doing this already. I'll show you this by going over an example that we discussed in the last lecture. That was, every sugar fiend loves every dessert. So the subject of this sentence is every sugar fiend, and we, in fact, translated that into first-order logic first. Because it's a universal statement, we know that we have to use a conditional, so we use the arrow, and then you see that the remainder remains untranslated. X loves every dessert, and that is itself a sentence for all practical purposes. Okay, and then the process just basically keeps on repeating itself. We have this untranslated part of the sentence, so we translate the subject of that sentence, right, into first-order logic. We leave the rest of the sentence untranslated. Let's once again go back to our example to see how that looks. So in our example, the remaining bit is X loves every dessert. And we can basically translate this using stuff that we already know. Right? And that's what we'll do. And this is what we end up with. We end up with the sentence which we saw in the last lecture. So we can see that the method that we've been using is fairly reliable for sentences of this sort. However, what I'm now going to do is introduce you to some places where the method breaks down a little bit. The most famous problematic case are what are called donkey sentences, for reasons that I'll explain in a second. But really, donkey sentences are just an example of a wider class of cases which don't fit tidily with this method. What I'd say, use the method, and you'll see something with donkey sentences, which I'll flag in a second, which tells you that it's not working out properly. And then what we'll do is we'll use that as a clue to say, like, okay, time to go back to the drawing board, maybe reinterpret the sentence, and then apply our method. And that's essentially what I'm going to do with this to show you how to properly translate the donkey sentences. So the reason these are called donkey sentences is because this is the example that sort of put its finger first on the problem. Apologies to animal lovers such as myself who don't like animal cruelty, but evidently this is how logicians think from time to time. Every farmer who owns a donkey beats it. Let's try to apply our method to this and see what happens. So recall that the first step of our method is to first translate the subject of the sentence into first-order logic and leave the rest untranslated. So the subject of the sentence is actually every farmer who owns a donkey, so it's quite complicated. But here might be the first way that you think to translate it. For all x, if x is a farmer and there exists at least one y such that y is a donkey and x owns y, then x beats y. So our next step, and it's really the last step here, is to take the rest of the sentence, which is just x beats y, and translate it accordingly. And so that just becomes what you see as the consequent of that embedded conditional right here. Beats, open parentheses, xy. However, this translation isn't going to work. Let me explain why, sad donkey. Let's look at the scope of the existential quantifier, there exists at least one y, right? We see that basically that ends at the end of that orange phrase that you see there. However, that means that there's no quantifier associated with the y in beats. Right? And remember, when we have what's called an unbound quantifier, the best way to translate that is as thing. So we don't actually have a proper English translation here. What we have is every farmer who owns a donkey beats thing, right? Not a good sentence. So the book gives you one diagnosis for this, and I'm going to give you another. I should just say we're going to end up with slightly different translations, but they're equivalent. I'm just flagging that now. I'll remind you of that again. Right? But for me, the root of the problem is the word a, as in a donkey, is actually ambiguous, and this happens quite a bit in English. Sometimes we mean a as in just one, and that'll be an existential reading, but really what we mean in this case is every farmer who owns any donkey beats it. In other words, it's not that a farmer has like a preferred donkey to beat, but he leaves the rest unbeaten. He beats all of his donkeys, would be the way to think about this. And once you see that, actually the sentence becomes much easier to translate. Let's see what it looks like. So if you think of this on the second reading, which you can think of as it's stated here, every farmer who owns any donkey beats it, or perhaps better, every farmer beats every donkey that he owns. Then you get the following translation. For all x and all y, if x is a farmer and y is a donkey, and x owns y, then x beats y. So recall with that first translation that we had, we ended up having this unbound variable, and we ended up actually not doing justice to the English, right? Now what you'll see is that doesn't apply in the second translation that we have on the bottom of the screen. If you look, the orange parentheses on the bottom blue box are highlighted, and that's the scope of our quantifiers, right? So there's no unbound variables, and we don't run into this problem, right? That's a good sign. And once again, to remind you, if you look in the textbook, you're going to see a slightly different formalization than the one that's in that bottom blue box. Don't worry about that. They are equivalent, and eventually you'll be able to prove that if you don't trust me now. So in addition to donkey sentences, the other thing I want to point to are English sentences which admit of two interpretations, what are called weak and strong readings. And what you'll have to do here is use a little bit of context and common sense to figure out what the appropriate reading is, whether it's a weak reading or a strong reading. Let's go through an example where we can get clear about what the weak and the strong reading amounts to. So some of you may be familiar with the work of Oliver Sacks. He's a British neurologist who writes a lot of popular science books. So one of his nice quotes is, "Every day a word surprises me." And this is a really nice example of a sentence which has a clear reading, but formally speaking, admits of both a weak and a strong reading. Since it'll prove instructive, let me be exceedingly pedantic about what this is saying. This is saying that each day that happens, there's presumably a new word which surprises Oliver Sacks, right, on that day. So the weak reading goes as follows. For all x, if x is a day, then there exists some y such that y is a word, and y surprises Sacks on day x. Now, let's contrast that with a very, very weird reading. This is what would be called the strong reading. What this says is basically every day Oliver Sacks wakes up and there's one and the same word that surprises him. So he wakes up and he hears the word banana and he's like, oh my God, right? And the next day he hears the word banana and he goes, oh my God, right? And et cetera, et cetera, et cetera, right? That's actually also consistent with the English expression, every day a word surprises me. But we would translate that different in first order logic. Basically what we would do is we would say there exists some y such that y is a word, and for all x, if x is a day, then y surprises Sacks on day x. So essentially what we've done is we've flipped the order of the existential and the universal quantifier, and with that we've had to also flip basically word and day in the sentence. Now obviously in this case the weak reading is the right way to translate what Sacks is saying, right? But there's going to be other cases where the strong reading is the right way to translate a sentence which might have a very similar grammatical form as the one you see right now. And all of this just depends on context, right? Nobody goes around being surprised by the word banana every single day, right? That would be weird, right? Or any other single word, right? You get surprised by a new word every day.
Thanks, and I'll see you at the next lesson.